Hi guys, so today I'm going to solve this question on resistors and resistance. So the question says, deduce the expression for equivalent resistance in the parallel combination of R1, R2, and R3. Then, which two resistors are in series, which two are in parallel, and if every resistor is connected to ohm, what current will flow in the circuit. So the first two parts are really easy, it's just that two connected in series are clearly R4 and R5, and the two in parallel are R3 and R2. Moving on to the harder part of the question, the third part. So the third part says that if every resistor is 2 ohm, what current will flow in the circuit? Okay, so let's start by considering the voltage at certain points. So if the current flows from here like this, then it goes down the ammeter, reaches this point. Now it's strong. So at this point, the voltage will obviously be 5 volts. We just ignore the internal resistance of the key and the ammeter. Now from this point, it goes right. It goes through this resistor, and it reaches this point. Okay. So at this point, the explain now. So at this point, the voltage should be less than 5, obviously, because of the resistor there. But we don't really know. It does not make sense to calculate it like you can, but let's just consider this as X for now. So yeah, and now the current splits up into the parallel connection. It goes, let's switch colors, make it more clearer. All right, so it goes here and it goes here. Then this goes up and here. Now we know that the voltage remains the same in a parallel connection. So the voltage at both these points will be the same. However, the voltage will obviously be less than X because it's going through two resistors. So we can consider it as an arbitrary value like Y. Right, Y. And it will be the same because it's a parallel connection. And an interesting part in this question is that there is a wire connected from here to here. And obviously, since it's connected, the the voltage at this point should also be wire. But now, see that let's just get back to the highlight. But no, now the interesting part of this thing is that this is Y and this is also Y. And for potential difference to flow through the resistor, for current to flow through the resistor, there has to be a potential difference between the 2 points, between the ends of the resistors. However, potential here is Y and the potential here is Y as well. Because there is no potential difference, there will be no current flowing through this resistor. So this will be red. I don't know what it's selecting. So this part will be red. Red in the sense there will be no current flowing through this part. And the current will directly go here. This eventually ends here. And as the current flows here, so this entire becomes the connection of R1, R2, R3. R1, there will be no current flowing through it. And R2, R3, they are both in parallel. So it's easy to find them. And then eventually, this ends back into R5 and ends up. Okay, so now I hope you'll understand that it's just calculations left. So this has been given as 2 ohm. This has also been given by as 2 ohm. Please ignore my handwriting. It's the laptop, so I can't really write and it's shaky. So R5 is also 2 ohm. And now these both are in parallel, so we just apply the formula for parallel connection, half plus half, entire is reciprocal, and this is just 1. And so you can reduce the entire thing into a single resistor like this. So you can remove this entire connection. Click, uh, and since this is also just pointless, you can remove this as well. So we remove this part as well. Here this on. And now this is not no longer R3 only. It's R2 plus R3 because we have just found the equivalent resistance to be 1. So this becomes R, oops, it's 2 flat. This becomes R2 plus R3. And that we just found out to be 1 ohm. And now it's just a series connection. So it goes from there 2 plus 1 plus 2, 2 plus 1 plus 2, which gets to be 5. So this entire thing has a resistance of 5 ohm, and we have to find the current. So just finish off the calculation thing. So that becomes current becomes 5 volts. It's not that clear. Get this color. All right, it's 5 volts by 5 ohms, which is just 1 ampere. So yeah, it was a good interesting question. Uh, this connection, the with the one we just removed, is actually called a Wheatstone bridge in some cases. This is not exactly a Wheatstone bridge, but it's a special case and it uses the same logic. So yeah, you can read about Wheatstone bridges later. And if you all have any doubts in this, just let me know in the comment section below, and I'll see you all in the next one.